So in our next example, we have a bunch of 3D shapes that have a characteristic of cylindricity. And that just means that they're round in one of their views. The cylinder, of course, is round in the top view. The cone, also round in the top view, tapering up to a point. Hemisphere, sphere, and slightly smaller diameter cylinder. But they all have this thing in common, that they are based on circles, right? And everything we've drawn up to this point has been flat, horizontal planes, vertical planes, or sloping planes. So let's talk about how to approach a problem when we're talking about something that is cylindrical. So if the shape I'm working with is a cylinder, or cylindrical in some form, then in one view it's going to look like a circle. And we see that case right here with our little block, right? So then the question is going to be, what does it look like when we look at it from one of those different angles? If this is the front view, what's it going to look like from the top? It's going to look like from the right side. And what we'll do is we'll spin it over and you'll get an idea of what it looks like. Okay, so now what we're seeing is we're seeing a rectangle. Okay, so now try to look at the shape without knowing aforetime or ahead of time that it is round. Right? Do you see the edges of the cylinder that make up that rectangle? You do. Now, how do we know it's cylindrical? Well, for one thing, we can look at the end and see it's round, but also, do you see the highlight and the shading? Right? So there are visual clues that light plays on objects to indicate if something is cylindrical or not. But if we were just drawing the profiles and edges, well, we wouldn't see those things, would we? So what's this side view going to look like? Quite simply, it is going to look like a rectangle of the same height as the diameter of the cylinder. Okay, so front view is round, the side view is going to be something that looks rectangular. Now, we probably remember from working with our sketches and working with some of our other drawings up to this point that round things, circles, arcs, they need to have their center point indicated. And we do that using something called a center mark. So I'm going to add mine here with a different color so it's a little easier to see. My center mark tells me where the center point of that circle is. Whenever something is cylindrical, we have to indicate in this view here that there is cylindricity. And the way that we do that is we imagine the axis of the cylinder going through that object. Real basic and as straightforward as I can. Imagine if we took our cylinder here and we found the very center of that side, and then we found the very center of this side. I'll just do it with my fingers. Can't we imagine being able to spin it around its axis? Right? The same thing with the sphere. Point and a point, if you held this by 2 points, you could spin it around the axis that connects the 2 points. And the cylinder would work the same way. I'd find the center, I'd find the point, and I can spin it on the axis that goes through there, as well as my hemisphere. Okay, so there is an axis describing the center point of this face to the center point of this face, and it's an invisible thing. It's not really there, but we can imagine a line from here to here indicating that axis of revolution. We can show it here on the sketch, and we'll need to show it on the sketch by adding a center line in that view. So now, why is that? What's going on? Why do we have to have a center line? Well, again, the idea is this is a cylinder. To show that it's cylindrical, the center line would let someone know, even if they never saw this view, that this can't just be a block. This can't be a square or a rectangular prism. It's got to be something that's got roundness, something that's cylindrical. Okay, and then the two things together, it's very clear to see what's going on. Now, not to make things sound too simple or too goofy, but there's one way that I used to teach my high school students to remember this, to stick that center line through the axis of a cylindrical object. And take a look at here. Does this sort of kind of look like a bow to you? A bow and a bowstring? Yeah, if you imagined, you could probably do a little theater of the mind here, and you see a bow and a bowstring. So if this is the bow and this is the string, this could be the arrow. And when you see a center mark, if you have multiple views, a side view, a top view, a bottom view, then just imagine you're going to shoot this arrow into the next view. Okay, so this is the arrow shot out of the bow from the center mark circular view into the next view. If you think that's juvenile, my apologies. I'm not trying to insult your intelligence. I'm just trying to set something up that'll be easy for you to remember. Okay, now we did the front view, we did the side view. Front view, side view. Is there any need to do a top view? What do you think? Well, the fact of the matter is, the top view would look exactly like the side view. So normally we don't want to draw things more than once if we don't have to. There's no reason to waste time. So in this case, we could say no need to make the top view. We can get by with two views on objects that are cylindrical.